Hello, geometry students. This is Mr. Fugay, and I am here to go over the Unit 7 exit ticket. So feel free to fast forward to wherever it is you need to work on or need to review. I will put timestamps in the description so that you can just fast forward to those places. Now, in questions 1 and 2, we have to do this problem without a calculator. Now, these were pretty difficult in the sense of, number 1, we needed to know our values of the trig toolbox. Now, the ones I'm going to write down that I'll be needing for sure in these are my 30, 60, 90 triangles. So make sure you know these, as well as my 45, 45, 90 triangle. That's 1 root 2. And then I'm also going to write in my key unit circle values that we need, especially when we're dealing with a quadrantal. So let's fill those in. And that's 1, 0. All right, so we'll need to use those throughout the problem. So in these problems where you're asked to evaluate the expression, there are 2 steps to use here. The first step is to actually evaluate the trig ratios. The second step is then using the order of operations, we have to try to simplify it into a single fraction or a single term. So when I look at number 1, we have sine cubed of 45. Now I want to remind you that that cube on the outside actually means quantity cubed. So really what this is sine of 45, and you're raising all of it to the 3rd power. So this is a common notation you're going to see with trig expressions, so I want you to make sure you pay close attention to that. So I'm sort of going to write a general skeleton here of this problem. It's going to be something raised to the 3rd power plus 7 times and then whatever cosine of 150 is. Now the numbers I'm about to fill in the blanks here, I'm going to get using my trig toolbox. Sine of 45 is going to be 1 over root 2. So that's exactly what I'm going to write down here. Cosine of 150 is going to be a negative answer because 150 is in quadrant 2, and based on the all students take calculus shortcut, that tells me that cosine is going to be negative. Now, reference angle of 150 is 30 degrees, since it's 30 degrees away from the x-axis. Cosine of 30 is root 3 over 2, and so that's what I'm going to fill in right here. Now, at this point of the problem, I am taking off my geometry hat and I'm putting on my algebra hat because we now need to simplify this expression using the order of operations. So my primary task is to first deal with this cube. When I'm cubing a number, what that means is I'm raising a number to itself 3 times. So in a fraction situation, just to kind of write it out here in plain terms, is essentially asking you to cube both the numerator and the denominator, like so. 1 cubed is just going to be 1. Now root 2 to the 3rd power, there's lots of different ways to handle this, but I think the easiest is to look at it written out like this and recognize that this is just going to be a perfect square. It's the square root of 4, which is just 2. And then leave that other root 2 in the problem like so. So 1 over root 2 raised to the 3rd power is actually equivalent to 1 over 2 root 2. Now for this next one, 7 is really 7 over 1. Anytime you have a whole number being multiplied, it's over 1. So when I multiply this, I'm going to get negative 7 root 3 over 2. So we have taken care of a major portion here of the order of operations. I cubed my number. I also multiplied it. Now, for the final step, we do want to write this as a unified fraction. Since both fractions have a denominator of 2 already there, I don't have to worry about that. But this first fraction has a root 2 in the denominator. I need that root 2 to be here in this other one to allow me to add them together. So I'm going to write in that root 2, but whatever I do to the bottom, I must also do to the top. So what I am doing mathematically is I am multiplying top and bottom by root 2, which is the equivalent of multiplying by 1. So my first fraction remains the same. My second fraction will now become negative 7 root, and when you take root 3 and root 2, that's going to give me root 6. So now I have 2 fractions being added together with a common denominator that will allow me now to add those together. Now 1 and 7 root 6, negative 7 root 6 are not like terms. You can only add radical terms if they have the same radical. Meaning if this 1 right here had a root 6 on it. So if it was like 1 root 6 minus 7 root 6, well, that you could combine and you would say that the answer would be negative 6 root 6 in that case. But that's not what we're dealing with here. These are unlike terms, and so I'm literally just going to write this as 1 minus 7 root 6 over 2 root 2. All right, we're going to move on to number 2 now. And in number 2, we are now going to do the same thing we did in the first problem, and that is kind of create like a skeleton here that we're going to have to fill in our 3 answers. Cosecant of 60 is the reciprocal of sine of 60. So a little side quest here. Sine of 60 is going to be, well, here's 60, root 3 over 2. And so since I know that, cosecant of 60 is just the reciprocal, which is 2 over root 3. Sine of 270, now 270 is going to exist here and is going to be a quadrantal. So I'm going to use this bottom value of my unit circle. Sine is equal to the y value, and so sine of 270 is just equal to -1. Finally, tangent of 330, that is going to be in quadrant 4, which means my answer is going to be negative. And then 330 has a reference angle of 30. Tangent of 30 is 1 over root 3. So once again, I have completed the trig geometry part of this problem. Now it is time to use some skills from algebra to simplify this. Now, there's a couple different ways to handle this. Strategy 1, which is not what I'm going to show, but you could effectively multiply top and bottom by root 3, and as long as you distributed that root 3 into the denominator, everything is going to cancel out because that gets rid of the complex fraction. But what I find for most students that is usually simpler is to actually look at the denominator, I'm even going to hide the numerator here, and get the denominator to be one term. That is, to get a common denominator. So what would be that common denominator here? I'll choose this color. It would be root 3 over root 3, because now I would be able to add these together. So this would be negative root 3 minus 1, so that's just plus -1, over the square root of 3. That is now my simplified denominator. So I'm going to come back here and let's write this all out so we can see what we're working with. We have 2 over root 3 all over now the new unified fraction root 3 minus 1 over root 3. We have a complex fraction. We have a fraction divided by a fraction, and when you do that, dividing by a fraction is the same as multiplying by the reciprocal. So that is going to give me this when I rewrite it. So the numerator stays the same, the denominator flips, those root 3's are going to cancel, and your final answer, simplified single term, is going to be 2 over negative root 3 minus 1. And that's going to be our final answer for number 2. Now, we are going to go ahead and move on to the equation section of this, numbers 3 and 4, and know that you can use a calculator for these problems. And based on the fact that it's 0 to 360, that means we will make sure our calculator is in degree mode. Now, one of the strategies I shared when you need to solve a trig equation is to first get the trig ratio by itself. And one way to do that to help simplify in your mind is view these sine thetas as like a variable, like an x. So like -2, I'm just going to write this out first. So just view these as like an x, because now what you're seeing is essentially a multi-step algebra 1 level problem. In this case, I would add 2x to both sides. 4 equals 7x plus 6. Subtract the 6. Lastly, divide by the 7, and you get -2/7 equals x. So in terms of the algebra process, that's all you have to do. Now, what we have to do next is the trig part of the problem. But before we do that, why don't we actually go ahead and get the algebra stuff done with number 4 as well. In this case, we're dealing with secants. So instead of writing secant, I am actually going to write it as x to the second power minus x equals 12. And so in this algebra 2 level problem, our goal is to zero it out and use factoring to solve our problem. So this will be x squared minus x minus 12 equals 0. When I factor the left-hand side, I need 2 numbers that multiply to get -12, but would add to give me -1. So in that case, I would use 3 and 4, make the 4 negative, make the 3 positive. When I solve each of these, I would get x plus 3 equals 0, which means x is equal to -3. First answer done. And then over here, when I solve x minus 4 equals 0, I get x equals 4. So that is the algebra of this problem, to get x, the trig function, by itself. Now, we need to transition in both of these problems back into a trig problem and evaluate it from here. So x is really not x. X was sine of theta. So let's write that. Sine of theta is equal to negative 2 over 7. Now, most of these problems, unless the number is a 0, 1, or a negative 1, is going to be have two answers because the sine ratio is negative in both quadrants 3 and 4. So my first answer will be quadrant 3. My second answer is quadrant 4. We're now going to need to figure out the reference angle, and this is where the calculator is going to play a crucial role. We're going to do inverse sine of 2/7. Notice there is no negative written here, okay? No negative. Because we've already accounted by the negatives by identifying the quadrants where these answers are. And whenever you remove the negative sign, the calculator is always going to give you the quadrant 1 answer. And the reason why you want that is the quadrant 1 answer is your reference angle. That's why we want to do this. So I put the sine negative 1 of 2/7 in my calculator. I don't have the calculator on screen to show you. But when I type that in, you should get 16.6 degrees. Now that we know that is my answer, we can now find our quadrant 3 and quadrant 4 answers. In quadrant 3, this would be 180 plus 16.6. So when I add those together, that gives me 196.6 degrees. In quadrant 4, the way I get this is 360 minus 16.6. And when I do that, I get an answer of 343.4 degrees. And that is our final answer for number 3. All right, and let's go ahead. I'm going fast, so if you need to rewind and listen to something again, go ahead. All right, in this problem, x was not really x, it was actually secant. Now I want you to see that we actually have two separate equations that we have to solve here. Secant theta equals negative 3 and secant theta equals 4. I am going to use the reciprocal property of equations to rewrite this in terms of cosine, because the reciprocal of secant is cosine, and the reciprocal of negative 3 is negative 1/3. And same thing over here. The reciprocal of secant is cosine. The reciprocal of 4 is 1/4. We have to treat these problems as two separate problems. So let's go over to the one on the left. Cosine is going to be negative in quadrants 2 and 3. When I go into my calculator to get the inverse cosine of, notice I'm writing positive 1/3 because I want my reference angle. Second cosine of 1/3 gives me 70.5 degrees. That means that my answer in quadrant 2 is going to be 180 minus 70.5, which is going to be 109.5. That's my first answer. And then my second answer in quadrant 3 is going to be 180 plus 70.5, and that gives me an answer of 250.5. And we're going to rinse and repeat one final time to wrap up this problem. So over here we have a positive 1/4. Cosine is positive in quadrants 1 and 4, and so I'm going to go ahead and take that inverse cosine of 1/4 again. Or not again, this is a different value, so let me rephrase that. We're using 1/4 this time. I get a reference angle of 75.5 degrees. Now, quadrant 1, that is my answer. The reference angle is the angle in quadrant 1. In quadrant 4, we would do 360 minus 75.5, and that would give me a final answer of 284.5 degrees. So what you will actually see for this problem 4 is that there are actually 4 different answers for the problem. And that will conclude this review of the Unit 7 exit ticket. Upon watching this, I will provide you additional problems of this caliber for you to try in class tomorrow so that you can see your growth and or if any new questions bubble up while you're practicing. But keep at it and continue doing the hard work you're doing, and this will get better as you continue to work through. All right, have a great day, everyone.